They are cold, fearsome, turbulent places, where the blustery winds screech at supersonic speeds. Immense behemoths, tens of times, even hundreds of times more massive than Earth. Not nice places to spend a quiet Saturday night. Yet, without them, well, there probably wouldn't be an us. Neptune, Uranus, Saturn, Jupiter, generally known as the gas giants. Huge collections of simple elements. But do they have solid surfaces? Solid cores?
The modeling that has been done for the giant planets indicates that it's possible that Jupiter and Saturn contain solid cores, maybe 15 to 100 Earth masses, but we don't have any real, excuse the pun, solid evidence for solid cores.
Solid or not, these regal leviathans like to encircle themselves with ring systems. All four of them have rings, each ring composed of an astronomical number of particles.
The particle sizes go from anywhere from the sizes of the finest powder that you might ski on in Utah, all the way to boulders or agglomerations of boulders as big as houses.
And embedded within the rings and affecting their shapes, a whole bunch of mini-moons, shepherd moons.
There are rather tiny moons that sort of play gravitational tag with each other and with the particles in the rings. There are gaps in the rings that are cleared out by some of these satellites.
The moons that actually have been seen to shepherd ring material between them or have an effect, a dynamical effect on the ring material around them, are believed to be objects that were originally in orbit around the satellite and either didn't grow very big or they were once big and they got smashed up.
Big worlds mean big gravity. Terrific tidal forces tear at everything near these planets.
The outer solar system planets have immense atmospheres dominated by hydrogen and helium. These are the lightest element gases that one can have.
And light elements can whip up into blustery breezes. Big winds make big storms. The famous example, Jupiter's great red spot.
It's been there for hundreds of years as far as we know, possibly longer. The inner core of the red spot may rotate in a different direction than the outer periphery of the red spot.
Jupiter, of course, at 11.2 times the diameter of Earth and 390 times Earth's mass, is the biggest world, at least in our solar system. We now know that many other stars nurture families of much larger super-Jupiters. Jupiter's four largest moons, Callisto, Ganymede, Europa, and Io, are easy targets for amateurs. Galileo was first to record their motions, and it caused him and ultimately the rest of the Christian world no small amount of soul-searching. Each of the Galilean satellites a sizable planet in its own right, with a unique personality.
The innermost moon, Io, or Io, some people call it, is the most active planetary body in the entire solar system. It has these volcanoes continually spouting off.
In fact, just one of the volcanoes on Io, called Loki, puts out more heat than all the Earth's volcanoes combined. We now know of 120 active volcanic centers on Io, and there are probably many more.
Ganymede is both old and new. It has some parts of its terrain that could be primordial, left over from the formation of the solar system, broken up by some new things, and we're not exactly sure what caused that breaking up and whether that's still happening. It is the only moon in the solar system that we are aware of that has its own magnetosphere.
There is as much liquid water on Europa roughly speaking, as there is in the oceans of our own planet Earth. And because Europa is smaller than Earth, that ocean's very deep, maybe 50, 70 miles deep. But the ice on top of it is probably pretty thin, maybe only 5 or 10 miles thick.
And when the geologists first looked at the pictures that came back, they said to themselves, holy mackerel, that looks like what we see in Antarctica when bits of pieces of ice break off of a glacier and they twist.
We have to go back to Europa to determine whether the crust is thin enough that the ocean can actually be sampled, the crust could be penetrated.
The outermost of the 4 large moons, Callisto, we originally thought was a cold, dead, heavily cratered world, and indeed its surface is just covered like the aftermath of a bombing raid with craters, and yet most recently the Galileo spacecraft has discovered that it probably has an ocean buried deeply below its surface.
It's incredibly smooth compared to other satellites around Jupiter and elsewhere in the solar system. Very few impact craters are seen on its surface, so its surface looks relatively new and fresh. And when you look at the surface in detail, what you see is this vast network of cracks that have reminded people of what ocean ice looks like, say, around the North Pole.
And of course, King Jupiter holds many more smaller moons at his court. Crossing the gulf now, between major orbits, to Saturn, long a favorite among amateur astronomers. Saturn's density is very low. Yes, it's true what you've heard. If you had a bathtub big enough, Saturn would float. Saturn sports a mob of moons, more than 30, and the count is growing. Chief among the interesting orbs that planetary geoscientists would really like to get some instruments on, Titan, Saturn's largest moon.
Titan is one of the most exciting places in the solar system and has been dreadfully underrated.
Titan is much more like a planet than any other satellite you can think of. It has a very dense atmosphere, it's got clouds, it probably has weather. There might be pools of liquid on or near the surface.
The liquid is not water, which is frozen stiff on the surface, but it's methane.
It's as big across as the US. It's one of the biggest satellites in the solar system. If in fact it had been in orbit around the sun, we would have called it a planet because it's about the same size as Mercury.
The atmosphere has a rich and complex organic chemistry going on, so in some ways it may be a snapshot of what the early Earth was like.
So here we might have a world much like Earth's, but where we have methane cycling.
The presence of molecular nitrogen and the presence of organic matter, the lack of oxygen, and its atmospheric density or pressure, which is about 50% greater than it is here on Earth, in those aspects, it very much resembles the atmosphere that scientists believe existed here on the Earth prior to the emergence of life.
And the only thing that it doesn't have going for it is it's very cold. It's 95 degrees above absolute zero at the surface, whereas in this room it's 300 degrees above absolute zero.
Beyond the majestic Saturn, you'll need your telescope, or a spacecraft like Voyager 2, to see these planets. Big as it is, the planet Uranus looked like a tiny green dot when it was first spotted by William Herschel, a musician turned astronomer. The count of moons at Uranus now stands at more than 20, but there may need to be as many as 40 or so to account for the sharp edges astronomers see in the rings around Uranus. The 5 largest moons, Oberon, Titania, Ariel, Umbriel, and Miranda, take their names from the fairy kingdoms of English literature rather than Roman mythology. That's a departure from astronomical tradition, instigated by Herschel's colleague, a brewmaster turned astronomer, William Lassell. Across the void once more, to the most distant planet in the plane of the Sun's equator, the beautiful blue Neptune. whose existence was actually deduced from the orbital behavior of Uranus. Out here, 4.5 billion kilometers from the Sun, that's 30 times Earth's distance from our star, you sure wouldn't expect enough heat to stir up Neptune's atmosphere. But something is causing storms to zip around in the hydrogen, helium, methane environment. Neptune has 8 known moons, 6 of them discovered by Voyager 2, and most notable among Neptune's regimen, Triton. Triton, along with Io and Earth, belongs to an elite club. All 3 sport active volcanoes.
Ground-based observers have been monitoring Triton over the past 10 to 15 years since the Voyager encounter, and we've noticed a number of changes, among them the atmosphere, the density increased by a factor of 2. We see a number of color changes on the surface. It looks like it may be getting brighter. It's a very active satellite.
Much of the surface of Triton is it's called cantaloupe terrain. It looks sort of like the surface of a cantaloupe. It's possible that Triton is an analog for the planet Pluto, which is of somewhat similar size and also in the deep recesses of the solar system.
Each of these titanic planet systems works, in essence, like a small star with attendant worlds.
They are solar systems in their own right, except take out the sun and put in a planet, and you have a very complex, very extensive system replete with a whole array of phenomenology.
Well, now the realm of the colossal globes is done. But before we leave these noble giants, a word of thanks is in order. You see, without these big gravity generators around to clean house in the early solar system, without their huge distributed mass to stabilize everybody else's orbits, conditions here on Earth would likely have been too chaotic to support the long continuing evolution of life. So, beyond the orbit of Neptune? Well, that's the other side of the tracks, and the population of objects living out there are very, well, you'll meet them later.